Hey guys, so greetings from my high school classroom. Let me show you guys what my classroom looks like here at the high school where I teach. Pretty cool, right? Little high school action. Brings back memories, does it? So now let's do two examples that have to do with what we did last time in class. So my camera is going to go off, but I'm still here. Let's do two problems right now. And your goal is to find the area of triangle ABC. And let's say that you're also given this. You're given that, they give you this, they give you that, and they give you this up there. So let's see how this goes. And maybe we'll actually only call this our only example because we did like almost everything in class last week. So this is like the leftover exam, or I should say on Monday. We did almost everything on Monday. So you see this on the exam. You want to find the area of this whole thing. We want all of that area, all of it, the whole thing. Maybe our strategy, guys, maybe our strategy would be to find the area of the pink and then to find the area of the blue and then to just add them together. So that's going to be my overall strategy. So first, let's focus on the pink triangle. So why don't we draw the triangle down here? It looks like this. It's a 3, that's 90, and that's a 5. And I know it's 90 degrees because this is also 90 degrees right there. You see that in baby blue? That's also 90 degrees. Now, I'm thinking because it's a right triangle, I'm thinking 1/2 base times height. But I don't know the height, this here. But I can go Pythagorean theorem. We can go 3 squared plus x squared equals 5 squared, where this is x right there. 9 plus x squared is 25. Subtract 9 from 25, and we get back 4. So our missing side for this triangle here would be 4. So now we have a base and we have a height, and we can go up there now. So the area would be 1/2 times the base times the height. And that's half of 12, which is going to be 6. So we just found that 6 is the area of this triangle here in blue. That triangle has area of 6. Now, let me erase most of this here, and then we can find the other triangle, and then we'll add the two areas together, and then we'll be done. So let's see. Let me get all this out of the way. The only thing I want to keep is that the area is 6, and also that this is 4. All right. So now why don't we focus our attention on this triangle here in pink? Let's draw it down there. And it looks like this here, where this is a 4 and this is a 7, and this is 90 degrees. And this now is unknown. So let's find the value of x with Pythagorean theorem. We can go 4 squared plus x squared equals 7 squared. 16 plus x squared is 49. So x squared is 33. If you subtract 16 from 49, and we get x equals the square root of 33. So right here, this is the square root of 33. So now I think that we can find the area of this triangle here. So let me grab a calculator real fast. And we can go area equals 1/2 the base times the height. And that's going to be approximately, let's see, let's type this into our calculators. And we get 2 square root 33, which is about 11.5. So guys, I think we're ready to finish this. We have 11.5 for the other half of the main triangle. So let me erase all of this here. 11.5 is what we keep. So this area, 11.5. So final answer would be 6 plus 11.5, because that gives you everything, right? Dude, that gives us everything. And that's about 17.5 square units. And there's actually one more thing I want to give you before you guys go. Let's actually do one more example, okay? One more, because something just came to mind. And I want to give you this info before you guys leave. So jot this down. The area of an equilateral, the area of an equilateral triangle of side length x is given by area equals square root of 3/4 times x to the power of 2. Where the model would look like this. You have an equilateral triangle, boom, 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 and one of the edges has a length of 6, or a length of x, rather. So equilateral triangle, if one of the legs is whatever that is, then the area is, boom, right there. It's given to you by this formula. So let's do one example using this formula, and then you guys can bounce, okay? So here we go. So why don't you guys jot this down? Maybe I can just type this in. Let's see. Find the area of an equilateral triangle whose perimeter, and spell today, whose perimeter is, let's say, 48 feet, period. Let me leave this up there. So find the area of an equilateral triangle whose perimeter is 48 feet. You might see this on the exam. Yeah, hopefully everyone's watching this video. You might see this on the test. So that's what we're doing an example right now. So let me grab my pen here. Model the situation. This is an equilateral triangle. And you know that all three sides are the same. So when it says perimeter, that means all three sides added together. So you know that it's going to be like a number plus the same number plus the same number. That's 48. So that's 3 of the same number, which is 48. So split it 3 ways. And that means that each edge is 16 feet. That's all that means, right? So we've just discovered that the perimeter divided by 3 tells us that each leg 16 feet. But the goal is the area. And based on the formula that we just have, this formula is exclusive to the equilateral. No one else. Only the equilateral. So take your 16 and drop it off right there. So the area would be square root of 3/4 times 16 squared. And let me reach for my calculator. Type this in here. You could like go to the nearest. You can probably go to the nearest 10th. That's probably what I'll ask for on the test. So about 110.9. And this would be square feet because they said feet. So we're going to be square feet because area is 2-dimensional. Okay, guys, so that video was short and sweet as promised. If you have any questions, email me, let me know. And have a great weekend. And I'll see you all on Monday when we will review for midterm 2. Bye.